Hi guys, I am Ashish and you're watching me on Medical India, and today's lecture is basically on test of hypothesis and test of significance. This is the 8th lecture of the lecture series based on the AIIMS PhD entrance. Okay, and I'm going to cover the full part of the section A, that is aptitude part, and this is the 8th lecture. Okay guys, so after this the 4 or 5 lectures will be left only. Okay, and I'll cover daily on the daily basis, and before 30 I would like to cover all the topics. Okay, so let's go ahead guys. So test of significance, what is test of significance basically mean? So test of significance basically is what is the significance of your research. So in research methodology lecture you all have studied about that the research is based on a hypothesis. Suppose if you are going ahead with a kind of research, then you have to allot a topic, or you can say the title of the project. So that title of project will refer your hypothesis basically. So hypothesis will be generated from your test title of the project on which you want to work, either in the PhD or in the research position. So guys, so significance testing is a process to assess the significance of difference between two samples drawn from the same population. In the earlier lecture I also have said about that there is a kind of population, and in the population there are a kind of different samples. So samples in a population, okay, or two closely related populations. So test of significance is the comparison between two samples of the same population or between the two populations. Okay, so test of significance is basically described by the null hypothesis. Null hypothesis, or generally you can say simply the hypothesis, is a statistical hypothesis laid down for testing a hypothesized assumption, and it is denoted by H0. H0 is the standard, you can say, convention to represent. So mu minus x, so mu can be here the sample 1 and mu x will be sample 2, or mu will be population 1 and x will be population 2. Okay, so the difference between the kind of mean, or you can say any parameter of which we have studied in the previous lecture about the central tendency. So difference between the central tendency will be 0 in the simple layman language if I'm saying. So alternate hypothesis will be the negation, or you can say the counterpart of the null hypothesis. Okay, so counter statement will be the alternate hypothesis, and the null hypothesis is the main, or you can say the hypothesis which you are going to prove through the research work, or you can say experimentation. So level of significance basically quantifies how significant is your work. Okay, so maximum chances of making false positive error or type 1 error, which we'll see in the next lecture what is type 1 error, or if you want you can visit the full lecture on biostatistics which I have covered for the ICMR JRF. It is also essential to go through for the AIIMS PhD entrance, the same lecture. Okay guys, so let's go ahead. Maximum chances of claiming false when it is true, it is a type 1 error. Okay, suppose the hypothesis is true and you have claimed it false. So the maximum chances of claiming false of the true statement is the level of significance, or type 1 error. It is denoted by alpha, and alpha is standardly set as 0.05, that is 5%, or you can say 0.05 proportion, that will be automatically what, 5%. So 5% is the level of significance by which you can ignore the kind of mistake. Okay, so guys, what happens while summarizing this slide, basically this slide is very important. Today's lecture is very crisp and it is very short. Okay, so let's discuss on this slide, because this is the crux of the full lecture. Okay guys, so suppose if you have started a research work and that research work is in a line on a title, so that title will be helpful in creating a hypothesis, and the hypothesis which you have derived from the title will be null hypothesis, and the negation, or you can say the counterpart or the opposite of the null hypothesis, will be the alternate hypothesis. So in the research work there will be a kind of instrumentation error and many errors while recording, or you can say if you are you have the questionnaire in the kind of research, or you have the molecular work, then handling problem, all these problems where you are having the error in kind of falsing the statement which is true, basically is the level of significance. So level of significance is acceptable when it is 5%. When you have 5% claimed false while it is true, then it will be acceptable. So this is denoted by alpha, and alternate hypothesis will be denoted by HA. So I think all the things will be clear now. So let's go ahead. So while you plotting the normal distribution from the data, in the data what happens, most of the like kind of data will be at the center. Okay, so the around mean value there will be much more data or the data values, and the extremes, that is the opposite extreme, you can say both the extremes have the smaller number of data. So the smaller population at the extremes and larger population at the around the mean value or the central tendency. So when most of the data, or you can say, are in the region around the center tendency, then it is the non-rejection zone, or you can say acceptance region. So please remember these sometimes these like graph is asked, these graphs are asked, and many questions raised from these kind of things. So this is a normal distribution from both the region. You have the rejection region where there is what, there is the, you can say this one, the false positive error. So false positive error you can see at the extremes, which is shaded, and alpha by 2, that is 0.025, that is 2.5% in the left, like you can say rejection region, and 2.5% in the right rejection region. So both will constitute what, the alpha, that is the 5%. So 1 minus alpha will be the non-rejection region. Sometimes it is asked, so non-rejection region is the actual experimentation which is done. So it will be 95%. So 95% of the data which is not the outlier, you can say, will be the acceptable data values. Okay, that will not give you the kind of any deviations in your result. So critical value is that value beyond which you are having the rejection criteria. So you will find both the rejection criteria in the left and right side. So critical value will be on the both side. So here everything is represented. In the first, you can say, portion, you can reject the H0. Okay, and in the second, do not reject H0. Sorry, H0 comes like in the shifted here. So that is the same part. Do not reject H0. So in the central part, you are not going to reject the hypothesis or null hypothesis. But again, in the what, in the right side, you are going to reject the null hypothesis. So this is the this is basically simple and very easily understandable, but you can have a kind of look into the graph, because many times questions are asked in these topics. So probability distribution comes into existence. Probability distribution is a mathematical function that gives the probabilities of occurrence of different possible outcomes. Here outcomes is the data values of an experiment. Okay, it depicts expected outcomes of possible values for a given data generating process. So suppose while experimenting you have a kind of data values. So the scatteredness of the data values basically is defined by the probability distribution. So probability distribution can be of two types, discrete probability distribution and continuous discrete probability distribution. In the discrete, you have binomial distribution where there is yes no type question, and Poisson's distribution where there is a more chances of some of the outcome to come than there will be the Poisson's distribution. And when you have the similar chances of doing the same kind of you can say the outcome, if outcome is suppose yes or no, not yes or no here, but the kind of thing where there is a uniformity, then you can say it is a normal distribution. So normal distribution is bell shaped, everyone knows. Okay, no one is going to ask you the formula in this exam basically. So but just remember the binomial distribution, yes no type, Poisson's distribution where yes has the highest weightage of getting that outcome, and normal distribution where the data is uniformly distributed or bell shaped, or you can say the symmetry in the probability distribution curve. Okay, so guys, normal distribution you can see here that mu is the mean median mode which is at the center, and 34.1% of the data is in the one standard deviation. Sigma here is the standard deviation. So z distribution you can calculate from here. Z value equal to the z value I was telling in like kind of previous lecture. So z value you can calculate from here. Okay, x minus mu, the sample mean minus you can say population mean by standard deviation is the z distribution. Okay, so the same thing, symmetric, uniform, bell shaped property of the normal distribution. And here 34.5 and 34.5% in the minus, matlab ki you can say in the negative one standard deviation and the positive one standard deviation. Okay, so guys, you can see that within the range of, you can say, the one standard deviation, both left right, there is a 68.2% data. Okay, so these types of questions are asked in examination, that we what is the value of data which will be in the one standard deviation, both left right combinedly. Okay, then you can see that here 8.2% data in the one standard deviation, and again 13.6 and 13.6, that is equal to 27.2. At 27.2, that will be around what, 96. So 95 to 96% data in the two standard deviation, you can calculate by adding it up. Okay, and only you can say key all the data in the three standard deviation, 99%, 99 point, you can say 8% data in the three standard deviation. Okay, so please remember this and calculate this by adding up, and you will get the these things. In the previous exam, they have asked about the what is the value in the first one standard deviation. So it is 68.2. In this two standard deviation, there will be 68.2 plus 27.2. That will be around 95.4% data will be in the two standard deviation. Okay, so 99% data in the three standard deviation, 99.8 or something like that. Okay, so please calculate these things and be alert, these types of questions can be asked. So skewness is basically the skewness and kurtosis. These two are the terms where there is a alteration, or you can say the deviations in the normal distribution curve. So when it is vertically, that is up down, then it is kurtosis, and when it is horizontally, that is left right shifting, then it will be skewness. So skewness essentially measures the symmetry of the distribution on the x-axis, as I said, left right. Okay, so you can see that mean is at the center in the symmetrical normal distribution, which is shown in the like central part. So there mean equal to median equal to mode. But when you come in the right side, then you can see that mode is greater than the median and then the mean. So mean is mean has the lowest value. Okay, so this is in the positive direction. Okay, so this is called the positive skewness, and negative skewness is just the opposite, where mean is smaller than the median than the mode. So mode is when greater, then it is negative direction. You can easily remember it. Why? Because generally what happens, mean is greater than median is greater than mode in the positive, and here mode is greater than the median is the, you are saying the mean, median and mode in random like kind of sayings, you can say mean, median, mode. So that is in the, you can say descending order, which is in the positive skewness. So positive, mean, median, mode. Here mode, median, mean, that is in the negative direction. So you can remember in this way also. Okay, kurtosis determines the heaviness of the distribution tails on the y-axis. Okay, so when it is higher, the curve has the highest peak, so the higher peak than the normal distribution, then it is called the leptokurtic. Okay, when it is the flat, then it is called the platykurtic. Okay, platy means flat, platy means plate, basically plate means flat. Okay, so platykurtic is where the flat curve is there. Lepto means tall, so taller than the normal distribution. But when it is of the same shape of the normal distribution but have kind of heaviness, you can say, then it is the mesokurtic. Mesokurtic is similar to normal distribution but have the heaviness. Okay, so you can remember these terms. These terms are basically asked for. Do not remember the formula kind of thing. That is non-essential actually for the examination point of view basically. Okay, so I have discussed this everything in the research methodology, but I have given you a task about the phases of clinical trial. So here I am going to tell you about the phases of clinical trial. Okay, so phase 1, phase 2, phase 3, phase 4. So best example is to understand from the coronavirus. What happens in the vaccine in the third phase trial, fourth phase trial, every different companies are in the different trials. So what happens in the phase 1 trial and how it is going to be approved for the phase 2 and then the phase 3 and the phase 4. So in the phase 1 trial, evaluate the safety and determine the safe doses, and it is basically the clinical pilot study. Okay, which basically identify the side effects. In the phase 2 trial, there is test effectiveness, further evaluate also the safety. In the phase 3 trial, confirm effectiveness. Here main is the effectiveness. Okay, first what happened, there was a weightage to the safety, and then they have approved the safety is there, then they have moved toward the effectiveness, then they monitor the side effects, okay, and compare to other treatments also and collect information. So in the phase 4 trial they are doing the everything kind of, they have in the phase 3 trial they have known then what is the side effect, what is the effectiveness, what is the kind of, you can say, the safety level, and everything they have decided by the phase 3. And in the phase 4 the main thing is the risk and benefit for the use in the things. So it is basically the part of the approval kind of thing, you can say. Okay, so the vaccine, corona vaccine, every vaccine is going through all these 4 trials. Not the corona vaccine, every drug, or you can say the treatment interventions, if they are they are all going through all these 4 trials. So guys, here is the description about all the trials, so you can go through it. So phase 0 trial is basically the exploratory trial, okay, where you can say that there is a pilot study. Okay, so there is no term like phase 0 trial, but phase 0 trials are all the trials which are just behind the phase 1 trial. Okay, so they are the phase 0 trial, they are basically the pilot study, observational studies, all those studies are the phase 0 trial. The same thing here, you can see that the number of subjects in the phase 1 trial is 20 to 80. Okay, and in the phase 2 that is 100 to 300, 1000 to 3000 in the phase 3, and number of subjects depend on the trial endpoints. So even the further more number of patients are there or subjects are there in the phase 4 trial. About the description which I have described in the like kind of previous slide, the same thing is here. You can see that the efficacy is done and the safety and efficacy in the phase 3 trial. So you can remember in this way, in the phase 3 trial all of the things are done. In the phase 4 trial only approval is left. Okay, in the phase 2 trial efficacy and safety, these 2 things are there. In the phase 1 trial side effect and toxicity. Okay, so if they give that what is done in the phase 3 trial, then please tick all the things. They generally ask the phase 3 trial, so tick all the things. So about the dose, this is a single dose and low dose of suppose if the treatment study has the kind of drugs, then a low dose is given in the phase 0 trial. Single dose, single ascending or multiple ascending doses are given in the phase 1 trial. Multiple doses and multiple trials are there in the phase 2 trial. Multiple doses trial and ascending doses are also given in the phase 3 trial. So this is actually the titration thing, you can say. So titration, or you can say the upgraded concentration of the doses are given in the subjects. So phase 4 is variable. Phase 4 no one is going to ask, because phase 4 is at the like kind of approval kind of thing. Okay, so basically the hot topic is phase 3, phase 2 and phase 1. These are the main important thing. So timings, if you are going to see, that can be conducted with prior approval in the phase 0 trial, but in the phase 1 trial they are conducted in an order, you can say. Okay, so this is the first clinical trial, basically phase 1 trial. Phase 2 trial conducted after report to FDA of the results of the phase 1 trial. This is the kind of thing subsequent, you can say, the upgradation. Phase 1, then phase 2, then phase 3. Okay, so the endpoints, basically endpoints is the termination of the clinical trial. So escalation of dose is, in the phase 1 trial you can see escalation of dose ends when unacceptable side effects occurs. So when the side effects are very less, then only that will pass to the phase 2 trials. Okay, and maximum tolerated doses can be used in the phase 2 trial. This is very important. So explores in the phase 2 trial explores the clinical effects against the targeted condition and reveals the less common side effect. Okay, so it discloses the less common side effects. Okay, in the phase 3 trial confirms clinical efficacy of the drug against the targeted condition and evaluate the safety and side effects. So safety and side effects were in the third phase 3 trial. And in the phase 4 trial, all the things kind of efficacy, you can say safety, side effect, approval, all the things are done in the phase 4 trial. So I think it will be clear. This is very short lecture and this is very crisp I have done, and I have just met the way to the, you can say, the examination point of view. Basically the weight in accordance with the examination point of view. So guys, I think this is all about the lecture. Please guys subscribe to the channel and share and like the video. If you have any query, you can connect with me on the social media platforms. Oh yeah, thank you so much guys, thank you so much for your kind attention.